In solving for a linear system, the first thing that you need to learn is to recognize the method that you can use to be able to solve for the solution of the linear system. We have three cases or three methods in which we can solve a linear system. On our first case, you will notice that in our linear equation, we have two equations of the form slope intercept form. Now, if you're given this type of linear system, the best way to use or the best method to use in solving for this particular case is the graphing method, because we can easily graph the first line and the second line and figure out the coordinate of the point of intersection of this linear system. Now, on our second case, we have a standard form, or we are given a standard form of a linear equation and a slope-intercept form of a linear equation. In this particular case, the most convenient method that we can use in solving for this linear system is the substitution method, which we have discussed in our previous lesson. Now, for our third case, wherein the first line is in standard form and the second line is also in standard form, we can use the elimination method in solving for the linear system for this particular case. So for today, we're going to focus on solving linear system of case number 3. Now, once again, the first thing that you need to learn in solving linear system is to recognize the method that would easily or best used to solve for the solution of the linear system. So now let's have some example of our third case in solving a linear system. Now, for this example, we have 5x minus 6y is equal to negative 32 and 3x plus 6y is equal to 48, which you know very well fall under case number 3, wherein line 1 is in standard form and line 2 is also in standard form. So in this particular example, elimination method is the best way to use in solving for the solution of this linear system. Now, if you will notice in this linear system, between x and y, we can easily get rid of y if we add them up together, because negative 6y plus 6y will turn into a 0. And that's the reason this method is called the elimination method, because we are trying to eliminate one of the variables to be able to solve for the linear system or finding the solution of the linear system given by this form. So for our first step, so since we can easily get rid of y in this particular linear system, we can cancel it or eliminate it, and we are going to have 5x plus 3x, which is 8x, plus 0 equal 16, because negative 30 plus 48 is equal to 16. So now we are left with 8x is equal to 16, which is x equal to 2, because we divided both sides by 8, so we can get rid of 8 by x. So now that we have the first coordinate of our solution, which is x equal to 2, we can now use any of these two lines to be able to find the value of y. So in my example, or in my first example, I'm using line 1, and we are replacing x variable by 2, which we found on step number 1, leaving us with 5 times 2 minus 6y equal to negative 32. So in this particular equation, we know that we can solve the value of y by getting rid of 10 and dividing both sides by negative 6. So therefore, y is equal to 7. So the solution of our linear system using the elimination method is 2 and 7. So this is our first case in this particular method, wherein we can easily eliminate one of the variables right away. For example number 2, my linear system is negative 2x minus 5y is equal to 22, and 10x plus 3y is equal to 22. This particular example is different from example number 1 because we cannot use the elimination method right away. Even though the first line is in standard form and the second line is also in standard form, you will see that there's no variable with the same coefficient. So in this particular example, we need to change one of the lines so that we can use the elimination method. And this is how I'm going to solve this particular problem. So for this linear system, which is negative 2x minus 5y is equal to 22 and 10x plus 3y is equal to 22, in this method, I'm going to change one of the equations by multiplying a constant to either line 1 or line 2 to be able to eliminate one of the variables. And by observation, I know that I can multiply 5 in line 1 so I can eliminate 10x, or the variable x. And that's what I'm going to do. So in this particular problem, you need to be able to recognize which variable is easy to eliminate. So now that I can multiply 5 on both sides of the equation on line 1, my line 1 will be changed into negative 10x minus 25y equal to 110. So I just simply multiplied every term in line 1 by 5 so I can get rid of the variable x. Now, you will see that on my second step, wherein the linear system is now changed, my elimination method can be easily used because I can get rid of the variable x, because negative 10x and 10x is equal to 0. So I have 0 minus 22y equal to 132 by combining or adding 25 and 3 and 110 and 22. So now that I have negative 22y equal to 132, I can easily solve for y by dividing both sides by negative 22, leaving me with y equal to negative 6. So now that I am through with the first step, which is finding the first coordinate, I can easily find the variable x by choosing line 1 or line 2 in solving for the x variable. So I'm using line 1 in this particular example, so I can replace y by negative 6. So now my equation will be negative 2x minus 5 times negative 6 equal to 22. And by solving for x, I'm going to have negative 2x plus 30 equal to 22. And getting rid of 30, which gives me negative 2x equal to negative 8, can give me the value of x, which is x equal to 4. So that's how I'm going to find the solution of my linear system. So for this example, my answer will be 4 and negative 6. So 4 and negative 6 is the point of intersection, or the solution of my linear system. Now let's have the third example. Now on my third example, I am given 3x plus 5y equal to 10 and 5x plus 7y equal to 10. From example number 2, we can change one of the lines, so we can use the elimination method to solve for x or y. But in this particular case, we need to change both lines to be able to eliminate one of the variables. So when you encounter this type of linear system, all you need to do is to decide which variable you want to eliminate. It's either x or y. So in this case, I'm going to eliminate x. And to be able to eliminate x, I'm going to multiply my first line with 5 and the second line with negative 3. And if you'll notice, I only interchanged the coefficient of my x's and make sure that one of them will be negative. So that is how you do this particular case for elimination method. You need to change line 1 and line 2 to be able to eliminate one of the variable. So there's a thinking involved before you can do the steps in elimination method. That's why this particular example is a little bit more challenging than the first two. So when you change your linear system by multiplying constant to line 1 and line 2, your new equations or system of linear equation will give you 15x plus 25y equal to 50 and negative 15x minus 21y equal to negative 30. And just like what we did on our previous example, we can now eliminate the variable x, leaving us with 4y equal to 20, which will give us y is equal to 5. And since we have line 1 and line 2, we can choose either line 1 or line 2 to solve for x. And now I'm choosing line 1 again and changing y by 5. So I have 3x plus 5 times 5 equal to 10. And by solving for x, I'll have 3x is equal to negative 15, and by dividing both sides by 3, x is equal to negative 5. So for this particular example, the solution of my linear system will be negative 5 and positive 5. And that is how we solve linear system using the elimination method.